All right, so in this video, I'm going to show you guys how to solve the problems on the quiz review. So first, for number 1 and number 2, it tells us to identify the vertical asymptotes and the horizontal asymptote of each function. Then we're going to sketch the graph. So first, let's look at number 1. So remember, if you look at your notes, to find the vertical asymptotes, you're going to set your denominator equal to 0 and solve for x. Those values are going to be where our function is undefined. So that is where our asymptotes are at. So we have x squared minus 2x minus 3 is equal to 0. We're going to factor that. That is going to be x minus 3. So we have x minus 3 and x plus 1. We would set each of these equal to 0. We have x minus 3 is equal to 0. Add 3 to both sides, and you get x is equal to 3. You have x plus 1 is equal to 0. Subtract 1 from both sides, and you're going to get x is equal to negative 1. So our vertical asymptotes are going to be at x equals 3 and negative 1. Next, we want to identify the horizontal asymptote. If you look at the notes, the horizontal asymptote, there's 3 separate cases to find which is which. And this specific example, our degree in our numerator is the same as the degree in our denominator. So this falls under case 3 in the notes. So when we have that, we're going to set the leading coefficient over the leading coefficient in the numerator over the denominator. So we have 1 over 1, right? There's a invisible 1 in front of our x squareds. So our leading coefficients are both 1, so we set it up as a ratio, and we have 1 over 1, which is the same as 1. So then our horizontal asymptote is at y equals 1. All right, so now we have both of those. Next, you know how to graph the function, so I'm not going to go over that. We can use the process of elimination. We're going to look at the options where the vertical asymptotes are x equals 3 and negative 1, and the horizontal asymptote is y equals 1. So option A is not correct because they have a different vertical asymptote. Option B, they have different vertical asymptotes as well, so it's not option B. Let's see option C. Option C, different vertical and horizontal asymptote, so it's not option C. And if you look, the answer is option D because they have the same vertical asymptotes at 3 and negative 1 and a horizontal asymptote at y equals 1. We're going to do the same thing for number 2. This one is a little bit more simple because we have 3x minus 3 is equal to 0. And you don't have to factor anything, right? We're going to add 3 to both sides. And you get 3x is equal to 3. Divide both sides by 3. And you get x is equal to 1. So our vertical asymptote is at x equals 1. The horizontal asymptote, again, this is a case 3 example. Our degree in the numerator is the same as the degree in our denominator. So we set this up as a ratio of our leading coefficients. So it's 1 over 3. So our horizontal asymptote is at y equals 1/3. You can graph the function in your calculator. You should know how. But we're going to use process of elimination again. Option A says that there is no horizontal asymptote. That is not true, so we're going to cross that out. And they also have a different vertical asymptote. Option B, they have 2 vertical asymptotes, but we only have 1, right? So that is not correct. And they also say the horizontal asymptote is at y equals 0. That's not correct. Option C, our vertical asymptote is at x equals 1, and our horizontal asymptote is at y equals 1/3. So that is the correct option. If you wanted to look at option D, it's also incorrect. Different vertical asymptotes. All right, so now let's move on to number 3 and 4. Number 3 and 4 are the same examples of 1 and 2, except we don't have to graph. So again, we're going to follow the same steps. We're going to set our denominators equal to 0 to find the vertical asymptote. So we have x squared minus x minus 6 is equal to 0. So we're going to factor that. We're going to get x minus 3 and x plus 2 when you factor those out. So you set both of those equal to 0. You have x minus 3 is equal to 0. Add 3 to both sides. You get x is equal to positive 3. Then you have x plus 2 is equal to 0. You're going to subtract 2 from both sides, and you get x is equal to negative 2. So our vertical asymptotes are going to be at x equals 3 and negative 2. And this also asks us to find the domain. So if you remember, the domain is going to be where our expression or function is undefined, and that is where our asymptotes are at, right? So our asymptotes are where our function is undefined. That domain of the function is going to be all real numbers except for where our function is undefined. So our domain is all real numbers except for x does not equal 3 or negative 2. Our horizontal asymptote, this is an example of case 1. The degree of our numerator is less than the degree of our denominator. There is no variable here, so the degree here is 0. The degree here in our denominator is 2, right? So 0 is less than 2. So the degree in our numerator is less than the degree of our denominator. When you have a case like that, there is going to be an asymptote at y equals 0. So let's look through the options. Option A, our vertical asymptote is at x equals 3 and x equals negative 2. Same thing that we have. Our horizontal asymptote is at y equals 0, which is what we determined. And our domain is all real numbers except for negative 2 and 3, which is also what we have. So the correct answer is A. You can look through the other options. They have different answers. Example 4. Again, we're going to start off by setting our denominator equal to 0. So we're going to solve for x. We're going to subtract 4 from both sides. You get negative 4x is equal to negative 4. Divide both sides by negative 4. And you get x is equal to 1. So our asymptote is at x equals 1. Since the asymptote is where our function is undefined, and our domain is all real numbers except for where our function is undefined, our domain is going to be x is all real numbers except for x does not equal 1. And then if we look at this we have a degree of 2 in our numerator and a degree of 1 in our denominator. So this is an example of case 2 when the degree of your numerator is greater than the degree of the denominator, there is no horizontal asymptote. So there is no horizontal asymptote. So let's look for options that look like this. Option A, the vertical asymptote is at x equals 1. That is correct. But the horizontal asymptote is at y equals 0. We have no horizontal asymptote, so option A is incorrect. Option B, vertical asymptote is at x equals 1. That's correct. Horizontal asymptote, there is none. That is also correct. And then the domain says all real numbers except for 1, and that is correct as well. So the answer is option B. Now let's look at the next 4. The next 4, we're going to be simplifying the expressions. 5 and 6, we're multiplying rational expressions. And then questions 7 and 8, we are dividing rational expressions. So if you remember from class, step 1, and I have this written on your worksheet, you have written down the steps for multiplying. Step 1 is going to be to factor everything. So let's go ahead and factor everything on example 5, right? And I'm going to go over to my notes so I can have more space to write. This is the same one, 20 to the third power minus 20n to the second power over 20n minus 20n squared times 4n squared plus 40n over n squared plus 16n plus 60. So let's factor. For our numerator and our first expression, both of them have a greatest common factor of 20, and they also share n squared. So we can factor out a 20n squared, right? All right, and then 20n to the third power divided by 20n squared, we're left over with just n. And then negative 20n squared divided by positive 20n squared is going to be negative 1. All right, so that is our numerator in the first expression. The denominator here, let's rearrange it first. We want to have our highest exponent first, so I'm going to rearrange this as negative 20n squared plus 20n. They both share a 20 and an n, so I can factor out negative 20n because we want our first n variable to be positive, right? We don't want to have negative n inside of the parentheses. So when I factor out negative 20n squared divided by negative 20n leaves me with just positive n. And then 20n divided by negative 20n leaves me with negative 1. All right, times, now I'm going to factor the second expression. So we have 4n squared plus 40n. I'm going to factor out 4, right? They're both divisible. Both our coefficients are divisible by 4, and they both share an n, so I'm going to factor out 4n. 4n squared divided by 4n leaves me with just n, and then 40n divided by 4n leaves me with plus 10. So I have 4n times n plus 10 divided by, and I have to factor n squared plus 16n plus 60. Two numbers that add up to 16 and multiply to 60 are positive 10 and positive 6. So this is x plus 10 times x plus 6. So I'm going to just, to save some time and space, I'm just going to extend my division symbol to signify that these are all on the same division symbol, and I'm going to simplify. So I can cross out what repeats, right? I can cross out the n minus 1. I can cross out n x plus 10. And 20n squared divided by negative 20n is just negative n, right? This cancels this out, and then this cancels out 1n, and we're left with just an n, but it's negative, right? And then we also have times 4n, because that's what was left over here, over, that's our numerator. Our denominator, we're left with x plus 6. So if we multiply 4n times n, we get negative 4n squared over x plus 6. Let's go back to our worksheet. And if you look at option B, we have negative 4n squared over n plus 6, the same answer that we just arrived to over here. All right, let's move on to number 6. So we have this expression, and I have it written out in my notes again, so I'm going to go to that. So we have x squared minus 2x minus 80 over x squared plus 9x plus 8 being multiplied by x squared plus 7x plus 6 over 6x plus 36. So first step, I'm going to simplify my expressions. So I'm going to factor the numerator in my first expression, x squared minus 2x minus 80. So two numbers that are going to, two numbers that are going to multiply to negative 80 and add up to negative 2 are going to be negative 10 and positive 8. Negative 10 plus 8 is negative 2, and negative 10 times 8 is negative 80. Now I'm going to factor the denominator in that same expression, and two numbers that add up to 9 and multiply to 8 are going to be 1 and 8. Right? 1 plus 8 is 9, 1 times 8 is 8. Times x squared plus 7x plus 6. I'm going to factor that. Two numbers that add up to 7 and multiply to 6 are positive 1 and positive 6. So x plus 1, x plus 6 over, and then in the second denominator, we can factor out a 6. That's what they share in common, right? So 6, and then I'm left over with x plus 6, right? So again, I'm going to connect these to show that they are in the same, and then I can simplify. In the test or the quiz, you don't have to find the domain, so we won't worry about that now. And this would be the next step, to find the domain, but we're not going to worry about that just yet. So I'm going to cross out what I can right now. So I can cross out x plus 8. I can cross out x plus 1s. I can cross out x plus 6. And then I'm left over with x minus 10 over 6. So x minus 10 over 6 is my answer. Let's go back to the quiz and look at option C. X minus 10 over 6.